Okay, students, let's look at the problem number 57. So we have automotive engineers refers to the time rate of change of acceleration as a jerk. So assume an object moves in a one dimension such that its jerk J is constant. So in part A, we have to determine expression for its acceleration, ax, t, velocity vx, and position x, given that its initial acceleration, velocity, and position ax initial, vx initial, and x initial respectively. So let's write down uh, that the rate at which acceleration is changing, which we call it dAx over dt. Of course, we have to write down time here, but mostly I think we might not write it here for now. So it's jerk, okay? Now, we have to find what kind of expression we can get for ax, vx, and just x, okay? Everything is moving in the x direction, okay? So let's rewrite this equation. We can write down this one as a dAx is equal j dt, okay? Now, if we integrate both sides, then we will get ax is equal j t and plus c constant. Now, our c constant, since it's acceleration and we have also initial acceleration, then we can say that our ax is equal gt plus ax initial, okay? Now, what about the velocity? How we can find the velocity? We know that first derivative of the velocity will give you acceleration, right? So that means if we say that our ax is equal dvx divided by dt, right? Then we can rearrange this one by saying dvx is equal ax times dt, right? So we already got our ax, which is equal to this one, which means we can rewrite that dvx is equal jt plus ax initial dt, right? Again, we have to integrate both sides. Okay, sorry guys, have to integrate both sides. Then we will get vx, which is equal to this one will give you jt squared over 2 plus ax initial t plus some constant c. Again, since we're looking at the velocity, then in this case our constant c is equal to vx initial. So we can rewrite this one again. Vx is equal jt squared over 2 plus ax initial t plus vx initial, okay? So that means we get for the velocity, we get for the acceleration. Now we have to find for the x1, right? So for the x1, we know that our vx is equal dx divided by dt, correct? So from here we can say that our dx is equal vx dt. Now we already got our vx, so we're going to substitute into vx. Then we can say that our dx is equal j t squared over 2 plus ax initial t plus vx initial and dt. Then we have to integrate both sides. Now if you integrate both sides, then you should get x is equal, this one will give you j t cubed over 6 plus ax t squared over 2 plus vx initial t plus c. Now again, in the case of c is equal to x initial, so we can rewrite this one again. X is equal jt squared, okay, cubed by 6 plus ax, this one is actually initial t squared over 2 plus vx initial t plus x initial. Okay, so now we got, for the last one, so we got for 3 of them, we got ax, we got vx, and also we got for the x. For the part C, I think it's just the same thing, you just have to substitute it and you will get what you're looking for.